Our assignment here is to find the minimum or and maximum of f of xy is equal to 4xy subject to the constraint x squared plus y squared is equal to 8. Now we are going to do this in this video step by step using the method of the Lagrangean multipliers. Hello there and welcome to the channel. Our first step is to rewrite the constraint in this form. So we have here x squared plus y squared minus 8 is equal to 0. All I have done is to collect everything to the left-hand side so that I remain with 0 here. The next step is to set up the Lagrangian. It's a function which we are going to call L, and it's of this form L, which is a function of x, y, lambda is equal to, we take our function f of xy here, so we have 4xy, and we subtract from it the constraint multiplied by lambda. So it's going to be lambda brackets x squared plus y squared minus 8. Close our bracket. So just to repeat, our Lagrangian, which is the function of x, y, and lambda, is this here minus the constraint multiplied by lambda. This whole thing here is called the Lagrangian, and the parameter lambda is called the Lagrangian multiplier. That's why the method is called the method of the Lagrangian multipliers. Lambda is the Lagrangian multiplier. Our second step is to find the stationary points of the Lagrangian. Obviously, there's going to be some differentiation here. So let's differentiate first of all with respect to x. So we will have partial L, partial x is equal to, here it gives us a 4y. Here it gives us a 2x multiplied by lambda. Differentiate with respect to y, we get partial L, partial y is equal to, here it gives us 4x minus, here it gives us a 2y lambda. Finally, we differentiate with respect to the parameter lambda, then it gives us here partial L, partial lambda is equal to all this here. It's minus brackets x squared plus y squared minus 8. Now, we are interested in the stationary points. And at stationary points, we know that all our derivatives are equal to 0. So we can equate each one of these to 0. 0. 0. Let's call this equation number 1. Let's call this one here equation number 2. Let's call here equation number 3. Now these are simultaneous equations, and we want to find the value of x and y that satisfy all these things. If you look at equation number 1, we can take this 2x lambda to the other side, divide both sides by 2x, and we end up with, let me try and use this one here, we end up with lambda is equal to 2y over x. We do the same here, we will end up with a lambda is equal to 2x over y. Now this is equal to lambda, this is equal to lambda, so this must be equal to that. So this means that our 2y over x is equal to 2x over y. Cross multiplying, it means x squared is equal to y squared, which of course means that x is equal to y. Now we can come down here to our constraint and replace our y with an x. So we can write here minus brackets x squared plus x squared minus 8 is equal to 0. We can get rid of the minus sign, and we are left with 2x squared is equal to 8, which obviously means that x is equal to plus or minus 2. Now, if x is equal to plus or minus 2, we know that x is equal to y, so y is also equal to plus or minus 2. This raises 4 scenarios, which are as follows. Either x is equal to 2 and y is equal to 2, that's scenario number 1, or x is equal to minus 2, y is also equal to minus 2, both of them are negative. The third scenario is x is negative, y is positive. The fourth and last scenario will be x is equal to positive and y is equal to negative 2. Now, what does this give us for the function f of x? When x is 2 and y is 2, that gives us 4 times 2 times 2, which is equal to 16. Let's write it in red. So here, our f of xy will be equal to plus 16. Down here, x is minus 2, y is minus 2. That gives us 4 times minus 2 times minus 2, which is again a plus 16. Over here, x is minus, y is positive. That gives us 4 times minus 2, which is minus 8, times plus 2, which is a minus 16. Here, x is 2, y minus 2. That gives us 4 times 2 times minus 2, which gives us a minus 16 again. So there are two values here. One is a plus 16 for f of xy. The other one is a minus 16. So we can conclude that our maximum of f of xy is equal to plus 16. Let's write it properly there. And our minimum is equal to a minus 16 for our f of xy. Those are the sought after values.